Okay, here, more or less, it was not that complicated, and we didn't really have to get involved with the partial fractions too much. Let's look at one where we have to have partial fractions. S times s plus 1, s plus 2. Now, in this case, we have to actually split it into multiple fractions. We know how to do it. There is a separate playlist on partial fractions. Have a look at that. This can be written as a by s plus b by s plus 1 plus c by s plus 2. So if we add up all these, what happens in the denominator? We multiply s times s plus 1 times s plus 2. So that time this gets cancelled. In the numerator, what will happen is a times s plus 1 s plus 2 plus b times s plus 2 c times s plus 1. This is equal to 1. Now let s is equal to minus 1. If it is minus 1, what will happen? This will become 0. Minus 1 plus 1. This will become 0. So first and the last terms disappear. So we are left with 1 is equal to b minus 1 times minus 1 plus 2, which is equal to minus 1 plus 2 is 1. So minus b is equal to 1, or b is equal to minus 1. Okay. Similarly, you see what substitution you can do to make one or two terms disappear. So let's say if I say s is equal to 0, what will happen? This term will disappear because of this s, and this term will disappear because of this s. So we'll be left with only 1 is equal to a times s plus 1 times s plus 2. Now here s is actually 0. So I need to actually do the substitution. 0 plus 1 times 0 plus 2, which is equal to what? 2a is equal to 1, or a is equal to 1 by 2. Okay. Now what do we do for the third term? So let s is equal to minus 2. If s is equal to minus 2, what will happen? This will disappear and this will disappear. Only c will be, c s times s plus 1 will be there. So 1 is equal to c s times s plus 1. So s times s we have to do substitution. So minus 2 times minus 2 plus 1. Correct? Yes. So now 1 is equal to minus 2c minus 1, or 2c equal to 1, or c is equal to 1 by 2. So which means our fraction 1 by s times s plus 1 times s plus 2 becomes 1 by 2s minus 1 by s plus 1 plus 1 by 2s plus 2. Remember, this was a. A is 1 by 2. So I have taken 2 down, 1 by 2. In the second case, in case of b, it is minus 1. So minus s plus 1. And the c is 1 by 2. So 1 by 2. Okay. So we have to figure out the Laplace transform of this. Here also it should be. Okay. We have to figure out the Laplace inverse. I'll just write it like that. Here I'll write Laplace inverse of Laplace transform. So which means this is L minus 1. Now we can split this into individual inverse Laplaces. So of 1 by s, 2s minus Laplace inverse of 1 by s plus 1 plus Laplace inverse of 1 by 2 times s plus. Okay, here 1 by 2 can be taken out, and we are left with Laplace inverse of 1 by s minus inverse Laplace of 1 by s plus 1 plus 1 by 2 inverse Laplace of 1 by s plus. Now 1 by s is The Laplace transform of which function? 1 minus 1 by s plus 1 is the Laplace transform of which one? E to the power of t plus 1 by 2, and this is the Laplace transform of e to the power of 2t. Yes. Now, what you should do is you should keep the table, right? A kind of a table in front of you so that it becomes easier for you to look up these mappings. So let me just uh, write down the table. In the process, while you are writing this table, automatically you will tend to slowly remember these things. So first, we start off with a function. Then we figure out the Laplace transform of this f of t, right? So now 1. If it is 1, then it is 1 by s. If it is t, it is 1 by s square. If it is t square, it is 2 by s cube. And in general, t to the power of n is n factorial by s to the power of n minus 1. Now, while doing this itself, just verify. If it is 3, then this will be what? 3 factorial by s square. 3 factorial is 6. So don't just look at these two and think that will go in, T3 will be 3 by S4. Not like that. Okay. So now if it is 2, then this becomes what? 2 factorial is 2 itself by n minus 1. No, this is plus 1. Okay. So while writing this itself, just verify. If it is 2, that is t square, then this will be 2 factorial by s to the power of 2 plus 1, 3. Yes. Similarly, if it is 1, it will be 1 factorial, which is 1 by s square. Okay. Now, in general, you see this can be written as f of s because these are all functions of s. We can write it like this or we can write it like this. Now, as a pattern, this would be 1 by s, 1 by s square, 1 by s cube, right? So when you are trying to solve inverse Laplaces, the function, rational function may appear to be in this form. This 2 you might have to introduce. Okay, similarly here it will be 1 by s to the power of n. So the opposite question you have to answer is this is the Laplace transform of which function? That is the inverse Laplace of f of s. So for this it is 1. For this it is t. For this it is t square. For this it will be what? Don't just look here and just write it. This will be t to the power of n minus 1 by n minus 1 factorial. So if it is 3, then this will be 3 minus 1, 2. So t square by 3 minus 1, 4 factorial. Okay. So be very careful with this. And remember, once we do that, what will happen is, for example, 3 we were doing. So this will be t square by 3 minus 1, 2 factorial. To cancel what? To cancel this 2, right? So that you end up with t square. T square. Okay. Now let's proceed further. If the function is e to the power of kt, its Laplace transform is 1 by s minus k. General form will be 1 by s minus k. So this would be e to the power of kt. Okay. If it is cos at, the Laplace transform is s by s square plus a square. This will also, the general pattern would be this s by s square plus a square. And this will be cos at. Similarly, sin at would be a by s square plus a square, a by s square plus a square, and this would be sine t. So as you can see, it is pretty straightforward. The only thing is you have to remember it. Now, if it is cos, that is hyperbolic cos of at, then it is what? Then it is, instead of s square plus a square, it is s square minus a square. A by s square minus a square cos at. Hyperbolic sine of at would be a by, no, not a by, a by s square minus a square, a by s square minus a square, hyperbolic sine of at, e to the power of kt times t to the power of n. This would be n factorial by s minus k to the power of n plus 1. And usually, while solving problems on inverse Laplaces, you might get it in this form: 1 by s minus k to the power of n. So what you'll have to do is you'll have to adjust it here. So the way this adjustment will work is e to the power of kt. This is pretty straightforward. You will end up with t to the power of n minus 1 by n minus 1 factorial. This n minus 1 factorial will cancel this n factorial, so that you end up with this. Okay. Then we have e to the power of kt sine at, a by s minus k square plus a square, a by s minus k square plus a square. And here it will be 1 by a, to cancel out this a, 1 by a e to the power of kt sine at. Naturally, what will be the next one? E to the power of kt cos at. This would be s minus k by s minus k square plus a square, s minus k by s minus k square plus a square, and this would be e to the power of kt cos at. And finally, the last two set is 2 sine at, sorry, t sine at would be 2as by s square plus a square the whole square. And generally this would appear like this. So s by s square plus a square the whole square. So you will write it as 1 by 2a times t sine at. So cos at would be s square minus a square by s square plus a square the whole square, and this would be s square minus a square by s square plus a square square, and this would be t cos at. What you will have to do is, given a Laplace transform, given this, what you will have to do is uh, you will have to do some manipulations. Most commonly technique is used is the partial fractions, and figure out to which pattern it belongs to. It may not match perfectly, so you'll have to manipulate it so that it matches, and then you'll be able to figure out the function whose Laplace transform it is. Okay, now that we have looked at this table, let's solve one more problem. Okay, so let's say we have to figure out the Laplace inverse transform of s to the power of 4 plus 3s plus 1 cube by s4 times s plus 1 cube. Yes. So first let's figure out, the partial fractions of, okay. So s4 plus 3s plus 1 cube by s4 times s plus 1 cube is equal to, now this is s to the power of 4. So this will get split. Because of this, there will be 4 partial fractions with the denominator as s, s square, s cube, and s4. Similarly, there will be another 3. with s plus 1, s plus 1 square, s plus 1 3 cube. Okay, so it will be a by s plus b by s square plus c by s cube plus d by s4 plus now s plus 1 cube because of that d e by s plus 1 plus f by s plus 1 square plus g by s plus 1 cube. Now here if you notice there are only two terms. Yes, s4 and s plus 1 cube. So which means that a, b and c they will all be 0, right? Because we will end up with only two partial fractions. Okay, so which of those? S4 is here, so d will have some value and s plus 1 cube will have some value, so d and g rest all, so even e will be equal to f equal to 0. So the only thing we have to figure out is the d and g. Okay, now here this would be as far as d is concerned. We are focusing on d now. So we will end up with d times, if we add up all these, what will we end up with? S4, s square, s cube we can ignore. S plus 1 cube is equal to s to the power of 4 plus 3 times s plus 1 cube, right? So let s equal to 0. So which means 0 plus 3 times 0 plus 1 cube is equal to d times 0 plus 1 cube, which means 3 is equal to d. So d becomes 3. Now let's look at g. S4 plus 3s plus 1 cube is equal to g, and in front of it what will be the expression? S plus 1 cube is there, so s plus 1, s plus 1 square is not required, but s to the power of 4 will be required. So this would be g s4. So now we can try to make this 0. So what will happen? S equal to minus 1. So minus 1 to the power of 4 plus this will become 0. Minus 1 plus 1 is 0 is equal to g minus 1 4, which means it is even power. So 1 is equal to g, or g is equal to 1. So g is equal to 1, d is equal to 3. So our function becomes 3 by s to the power of 4 plus 1 by s plus 1 cube. And we have to figure out the Laplace inverse transform of 3 by s to the power of 4 plus 1 by s plus 1 cube. Yes. Now this we can split it into two parts. We can say inverse Laplace of 3, we can take it out. So we end up with s4 plus Laplace inverse of 1 by s plus 1 cube. So 1 by s4. So let's look at this. 1 by s4. 1 by s to the power of n. So 1 by s to the power of 4. This would be what? T to the power of 4 minus 1, 3. 4 minus 1, 3. So t cube by 3 factorial. 3 times t cube by 3 factorial plus now 1 by s plus 1 cube. 1 by s plus 1 cube. 1 by s plus 1 cube. Okay, look at this. S minus k can be written as s plus minus k, right? So this will become what? E to the power of minus kt minus e to the power of minus 1, because in our function it is plus 1, so this will become minus 1. So e to the power of minus 1 times t to the power of n minus 1. N is cube, so 3 minus 1 square, so 2 it will become. So 2 square by 3 minus 1, 2 factorial. So this will become e to the power of kt. Here k is 1, so this will become minus 1. T n minus 1, so 3 minus 1, 2 by n minus 1 factorial. So 2 factorial, which can be written as 2 itself. Now if you want, you can see, this is 3 times 2. So 3 factorial can be written as 3 times 2. So what we can do is 1 by 2 times t square, we can take it out. Yes, this 3 and 3 cancels out. We can write it as t square, we have taken it out, t. So t cube by 2 plus e to the power of minus 1. So just verify it. T cube by 2, t cube by 2 plus e to the power of minus 1 t square by 2. So this would be the inverse Laplace transform of the given function of this one. Okay, I think that's enough. You need to practice a lot to get comfortable with all this. Bye for now.